Welcome to another edition of Math for No Reason. In this edition, we look at this problem which says that suppose we have positive numbers a1, a2, an and we have numbers p1, p2, pn, all of which are greater than 1, and we satisfy the relation that summation of k equal to 1 to n, 1 by pk equal to 1. We have to show that the product of these ak's is less than equal to the sum of ak to the power pk divided by pk. And to do this result, we will have to use an inequality which is known as Jensen's inequality. It is usually stated in terms of convex functions and expected value of random variables. So suppose x is a random variable with expected value e of x and phi is a convex function, then phi of expected value of x is less than equal to expected value of phi x. The most well-known example of this is the result that e of x whole square is less than equal to expected value of x square. Here, of course, we are using phi x is equal to x square here, which is a convex function, and this is this result for us. Now, let us look at xk and let that be log of ak to the power pk, and which is pk log a. While pk's are not themselves probabilities, but through this relation we see that 1 by pk's are probabilities. So if I call qk as 1 by pk, then we note that each of these qk's are strictly positive, each of them is also less than 1, and the sum of these qk's is equal to 1. So the qk's form a probability distribution. This is an important thing to note because we want to use the Jensen's inequality. Now, the hint is that we have taken a log of ak to the power pk. So, to get back ak to the power pk as required in the problem, we need to look at e to the power xk. So, e to the power xk is ak to the power pk. So, let us remember these results. So, phi x is equal to e to the power x is the convex function, very easy to check. The second derivative of phi is e to the power x, and hence that is greater than 0. So, phi x is a convex function. So, let capital X be a random variable which takes the value x1, x2, xn with probabilities q1, q2, qn. Now, we can apply the Jensen's inequality. The expected value of x is summation of k equal to 1 to n xk qk, and therefore phi of expected value of x, which is the left hand side here, is e to the power summation k equal to 1 to n xk qk, and remembering that this is pk log ak, we get this as e to the power summation k equal to 1 to n pk log ak into 1 by pk, and that is nothing but e to the power summation k equal to 1 to n log ak, and that is product of k equal to 1 to n. So, we have obtained the left hand side as phi of expected value of x. So, we have already noted that phi of expected value of x is product of the ak's. Now, let us compute the expected value of phi x. Expected value of phi x is summation of k equal to 1 to n qk into phi of xk, and that is summation of k equal to 1 to n 1 by pk into e to the power xk, and e to the power xk is just ak to the power pk. So, this gives us 1 by pk into ak to the power pk, and we note that this is exactly same as the right hand side of the inequality that we have to prove, and therefore by Jensen inequality we get a equal to 1 to n ak is less than equal to summation of k equal to 1 to n 1 by pk into ak to the power. So that proves our claim. Now let's look at a special case where these pk's are all equal to n. So let p1 equal to p2 equal to pn equal to m. Then we have summation k equal to 1 to n, 1 by n is equal to 1. And what do we get from this inequality? We get that product of k equal to 1 to n ak is less than equal to summation of, so which is equal to 1 by n summation of k equal to 1 to n ak to the power n. And it is easy to see that the left hand side is the geometric mean of a1 to the power n, etc., an to the power n. So that is the left hand side, and the right hand side is the arithmetic mean of the same quantities. Now, since these are all positive, we can replace a1 to the power n, etc., as yi's, and then we would have our well-known ANGM inequality. So by taking yi equal to ai power n, we get that product of k equal to 1 to n yk whole raised to the power 1 by n is less than equal to 1 by k summation k equal to 1 to n yk. So this gives us the conventional ANGM inequality. The GM is less than equal to a. Thank you.